This video goes over how to apply the fundamental counting principle, which counts the number of outcomes given a particular variety of choices. So example 1, at a family picnic, you have 2 types of burgers to choose from, beef or veggie. You can have your burger with or without cheese and with 1 topping of tomato, lettuce, ketchup, or pickle. So the first thing that we're asked to do is draw a tree diagram. So I'm going to start with my types of burgers. I've got beef or veggie. Then in the next branch of my tree, I'm going to include my next set of options, which would be cheese or no cheese. Same thing for my veggie burger. And then finally, the third branch, I'm going to include my topping options. So tomato, lettuce, ketchup, or pickle. Same thing down here, tomato, lettuce, ketchup, or pickle. Tomato, lettuce, ketchup, pickle. Last branch, ketchup, pickle. So now what this does is it tells me my possible combinations that I can find for a hamburger. So if I follow my first branch here, I could have a beef burger with cheese with tomato. So B, C, tomato. Now if I go along my beef option, I could have beef, cheese, and lettuce instead. Beef, cheese, lettuce. Still staying with beef and cheese as my first 2 choices. I have a third option or permutation with ketchup as my topping. And then finally, I could have beef, cheese, and pickle. Now I could go all the way through. This would keep going. But in total, I'm going to have 16 different burgers. So 4, 8, 12, 16, just from counting all those branches in the tree diagram. So as you can see, this would get a lot more complicated if we have more options and more possibilities for each option. So we can actually use what's called the fundamental counting principle, where we can just multiply the number of burgers times the number of cheese options times the number of toppings. So we've got 2 choices for burgers, 2 choices for cheese, cheese or no cheese, and then 4 options for toppings. Multiplying all these together is going to give us 16, which is our total number of combinations of those options. So mathematically, this is called the fundamental counting principle. And if we have n tasks, let's say they're called A1, A2, A3, all the way up to AN. If each of those tasks can be conducted in A1, A2, A3 ways, respectively. So A1 would be like our burgers. Little a1 would be the number of choices that we have. Then we can find our n tasks together can be conducted in, so A1 times A2 times A3, all the way up to AN, different ways. So multiplying your number of options for each task that you're looking at. So let's look at another example. Example 2, Canadian radio stations have a 4-letter call sign. For example, CKCO. Each of them begin with a C. And we want to know how many different call signs are available. So for our first option, we only have 1 letter as a possibility. We know that it has to be a C. For our second letter, we've got 26 possibilities, 26 letters in the alphabet. Third possibility, we've got 26 again, because it doesn't matter if it repeats. And then our fourth letter of our call sign, we also have 26 options. So multiplying those together is going to give us the number of different call signs. So 17,576 different call signs are available. Another example here talks about what happens if we can't have a repeated color. So we've got 3 rows on our flag here, R1, R2, and R3. And we want to know how many ways can we color the flag if we have 8 colors to choose from, but the same color can't appear twice in a row. So for R1, we've got 8 choices because we have 8 colors. For R2, since we can't have it repeat, we can't use the same color that we used the first time, we now have 7 colors for R2. Okay. For R3, we have another 7 options. We just can't repeat that first color. Multiplying them all together gives us 392, which is the number of ways that we can color the flag. Our last example here is arranging books on a shelf. So I have 5 different math books that I want to arrange, and I want to know in how many ways that this can be done. So for my first spot, I've got 5 choices because I've got 5 different books. Now that I've already put one book on the shelf, I only have 4 to choose from for my second spot. Similarly, 3 for my third spot, 2 for my fourth spot, and then by the time I've already put 4 books on my shelf, I only have 1 more option. Multiplying those together give me 120 ways that I can arrange 5 different math books on a shelf.